Part 4, coordinate plane. So today we want to introduce this new concept about coordinate. A coordinate plane is, as shown here, is a flat plane formed by the intersection of two lines or two axes. We call this the horizontal one as x-axis, the vertical as y-axis, and we mark them as different units. And this would give you the exact location. If you at any place, if you have a point, we can give you the location of that place. Just like if you walk out of your door, you say, I turn right 2 blocks and then turn left 2 blocks, I would get to a certain store. This is the same way. You start from the origin right here at the cross section. For example, this P point. You go to your right by 3 units and go up by 5 points. That would give you P of 3 and 5. So that's your location. We call that, we give them a brackets, and we have 2 numbers, 3 and 5. The x-axis, the horizontal location, always goes first, and the vertical position goes second. So P35, which is exactly the location for point B. And we also call this, since we have 2 lines that separate the plane into 4 parts. Here is 1, here is 1, here's 1, here's 1. The 2 lines extends infinitively. So we call this quadrant 1, 2, 3, and 4. This is a counterclockwise. So let's look at some real problems. So when we have this x-axis and y-axis, and we can perfectly identify the points, the locations of all points. For example, this point B, so this is 0, this is 1, this is 2. Point B, the location would be, we first go horizontal distance from the origin, 1 and 2. So B has a horizontal location of 2 and a vertical position of 1. And A, horizontal position first, go 1, and then we go 1, 2, 3 up. So the vertical position for A is 1, 3. So in this case, point A and point B is completely identified using these pair of numbers. And same goes for C and D. Let's look at this question. 2 of the vertices of a parallelogram that contains trapezoid ABCD are 1, 3, A, and 2, 1. That's B. The parallelogram has twice the area of trapezoid ABCD, and its coordinates are positive. What are its other 2 vertices? Okay, we want to find a parallelogram which will look something like this or something like this. That is twice the area of ABCD, the trapezoid here. So if we extend, if we have 2 of the trapezoid, then your area would be twice. So if we extend this, so B to C has 1, 2, 3 units. So if we have 1, 2, 3 units, from A to D, horizontal distance 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. So in this case, if I call this number as M, if I call this place as N, parallelogram A, B, and M would have 2 trapezoids that are identical. Therefore, the parallelogram would be twice the area of A, B, C, D. So let's look for what's the coordinates for N. N is here, has an X location of 10, has a Y location of 1. What is M? M is horizontal location of 9 and vertical location of 3. 2. An isosceles trapezoid has a line of symmetry. 2 of the vertices of the isosceles trapezoid are 1, 6, 3, 2, and 7, 2, as shown. So we have 1, 6, 3, 2, and 7, 2. What is an isosceles trapezoid? Which had isosceles meaning the two sides are identical. So the symmetry goes in the middle. So now we need to find the fourth vertex. The vertex has the whole number of coordinates. And if we say this one has the sides, so this is one of the sides. Say, let's assume this is one side. So we have 1, 2, 3, 4. 1, 2, 3, 4, which is the same as this. Now we need to have exactly the same on the right hand side as the left hand side. So from the top of this shorter side, we can see that here are 2 units, right? So on the right hand side, this need to go out 2 units as well. So this would be an isosceles triangle. So this extra area on each side, they're the same. Okay, so now we need to find this location. This location would be 9. Let's call that M. Point M has a horizontal location of 9 and vertical position of 6.